Hi everyone, welcome to my channel Design with Roosevelt. Continuing with CSWA Practice Problems, today we'll work on question 512. I know it's quite surprising because in a previous question I mentioned question 511 is the last question of section 5 of the problem set. However, I recently noticed that SolidWorks uploaded a new version of the problem set, 2026 version. The version that we're working on right now is 2024-2025 problem set. And in this problem set, question 11 is the last question. However, in the updated version, which is 2026 version, there are more questions in section 5. So what I'm going to do, starting today, I'm going to work off of the new version and updated version of the problem set, which is the 2026 version. This is a great opportunity. We can learn much more and we can practice more. If you don't have a 2026 version already, I recommend you just go and check the description in this video. You can click on the link, and once you click on the link, you will be redirected to SolidWorks website. Let me show you. So if you click on the link in the description of this video or any other videos on my YouTube channel, you will be redirected to this website. And all you need to do in this website is to put in your email address, click on next. Then after that, you can put in some basic information like your name, company, whatever. And then after that, you're going to get access to two different problem sets. First one is a CSWA, which has 250 questions. And the second one is CSWP. This is absolutely new. Now they release new sets of problems for CSWP. We will focus on CSWP later, but for now my focus is on CSWA. So we are going to work on all these questions starting today. Okay, I hope this is clear. So now let's go back and start working on question 512. In this question, unit of measurement is millimeter gram second. Like always, we need to ensure we are using the same unit of measurement in SolidWorks setting. Now looking at this question, we have the 3D model. We have the top view, front view, and the right view. My preference is to focus on the back side of the geometry. I'm going to start with this base of the geometry, the rectangular shape. Then I will focus on this top section. After that, I will focus on the middle section, which is this extrusion that we have here. Then I'll focus on the circular section. And as a last step, I'm going to focus on the rib here. You can't see this rib in this view because it's hidden underneath the middle section. However, in the front view, you can see that we have a rib. So I'm going to focus on that part as a last step. Okay, so with this introduction, let's jump into SolidWorks and start modeling this part. In SolidWorks, first we need to check unit of measurement, and you can see that we have millimeter gram second, which is a correct unit of measurement. Now let's click on the sketch, and let's choose right plane. So here, I'm going to start with the rectangle command. So I click on rectangle, and then I make a rectangle here. According to the right view, we can see that the width of this rectangle should be 75 millimeter. Also, looking at the front view, you can see that the height of this rectangle should be 50 millimeter. Now we need fillet, 6 millimeter and 25 millimeter. So let's click on fillet command. Let's change this to 6, and let's click on top right corner and top left. Click on OK, and that's it. Now change the radius to 25. Click on bottom one, these two. Click on OK, and that's it. So that's the first part. We have the sketch. Now we can click on feature, click on extrude bus, and according to the front view, the thickness that we require is 13 millimeters. So I change the thickness to 13, click on OK, and that's it. Awesome. So now we have this first part of the geometry made. Next, let's focus on the top section here. Click on the sketch, and select this top surface. Because it's a symmetric geometry, click on the drop-down menu, click on the center line, and then here, let's make a center line, something like this. Let's click on line, and let's start with the line here. Next, I click on arc command, and I'm gonna need arc shape, something like this. First, click on a smart dimension, and the length of this line should be 3 millimeters. According to the top view, the radius of the arc should be 45 millimeters. Also, because it's a symmetric design, the center point of the arc should fall right on this symmetry line. So I click on the center point, I hold Control, I click on the center line, and I choose coincident. Also, the distance between this line and a mirrored line on the other side should be 50 millimeters. So this is 50. And now you can see the geometry is fully defined. Let's add a line from this point to this center point as well. And now we have this part of the geometry. Because it's symmetric, from a sketch, I'm going to click on Mirror Entities. I select this line, I select this one, I select this one, and for mirror line, I'm going to select this center line. And now you can see the preview. Click on OK, and that's it. So now we have the sketch. Now let's click on Feature, click on Extrude Bus, and then here the contour is selected. Change the height to 35 millimeters according to the front view. Click on OK, and that's it. Awesome. So now we have the second part of the geometry modeled. Now let's focus on a third part, which is the extrusion in the middle section. So in order to make that part, let's click on a sketch, and again, I'm going to select this top surface. Here we are dealing with a symmetric geometry again, so I click on the drop-down menu for the line command, and I choose center line. And I'm going to draw this line just to help me with the modeling. Okay, so that's a center line. Now here, all I need is a rectangle. So I click on rectangle command, and I'm going to make this. Of course, this rectangle should be symmetric. So I click on this top line, hold Control, symmetry line, keep holding Control, selecting this bottom line, and from the options, I'm going to choose symmetric. According to the top view, the width of this rectangle should be 38 millimeters. So this is 38. According to the top view, the length of this line, or the distance between this right side and the left side of the geometry, is 85 millimeters. Okay, so now we have this rectangle. We need a fillet in this corner and this corner. Now here's the tricky part. If you look at the question, you see the fillet, but you don't see a radius for the fillet. And that's a challenging part. If we don't know the radius, how are we supposed to make that fillet? There's a small detail here that we need to pay attention to it. If you look at the corner of the geometry and the right view, you can see that the edge of the fillet, we're going to have a fillet here. The edge of that fillet is in line with this top edge of the arc. So the blue line that I'm showing here should be in line with the edge of the fillet. We don't know the size of the fillet. However, we know that from the right view, the edges must be on the same plane. So let's see how we can use that to find the fillet. What I'm going to do here is I click on center line, and I'm going to draw a line as a reference. This line is right in line with the top edge. And now here, because I need a fillet is basically an arc shape. I click on arc command, and I'm going to make something like this. Of course, because it's a fillet, I want this curve to be tangent to the top surface. So I select the tangent relation. I want the arc to be tangent to this edge as well because it's a fillet. So I select tangent. And now you can see this curve is fully defined. This point is not defined, but it's easy. Click on the point, hold Control, click on the line, and choose coincident. And now you can see the arc that I have here is fully defined. Now if I click on a smart dimension, I can see that the radius is 6 millimeters. So basically the radius that is not shown in the question should be 6 millimeters. But again, we don't know it. And the way that we found this was by reverse engineering it, by the fact that we know that the edge of that curve should be in line with this top edge. Okay, so now we have this. Let's close this sketch, and this is our fillet. Now we need this fillet on both sides, so from a sketch I click on mirror entities, I select this one, I select this. For mirror line, I'm going to select this center line, and now I click on OK. So now I have the fillet on both sides. We are ready to extrude this geometry. So click on feature, click on extrude bus, and then here I select this one, I select fillet contour and fillet contour. Of course the direction is not correct, so I change the direction, and according to the right view, the thickness of this section should be 8 millimeters. So I change it to 8, I click on OK, and that's it. So this is the middle section. Now if you look at the right view, you can clearly see that the edge of the fillet is in line with the edge of the top section of the geometry. Awesome. So next we want to focus on a circular section here. So let's click on the sketch, and let's choose top surface. Now here I need a circle, and the diameter of the circle is equal to width of the geometry, which is 38 millimeters. So click on circle command, and here I make a circle. Of course this circle will be fully defined, and I don't need to add dimension because the diameter is equal to the width. So this is fully defined. Click on feature, click on extrude bus. Now according to the front view, we need to go 10 millimeter in a positive Y direction. So this height should be 10 millimeter. We also need to go in negative direction as well. So what I can do, I can activate direction 2. And then here for the overall lengths, I know that the total length of this circular section is 30 millimeter. I know that 10 millimeter was on a positive side, so 30 minus 10, which is 20 millimeters, should be on the negative side. So click on OK, and that's it. Next, I click on a sketch, and I draw a circle in the center. This is a circle. Now, according to top view, we know that the diameter of this circle should be 13 millimeters. So now we have this circle. Click on feature, click on extrude cut, and we want to cut all the way to the bottom surface. So you can choose through all. Click on OK, and that's it. So now the circular section is also made. Last step is to focus on a rib in this geometry, which should be located in this bottom surface. This part is quite tricky because it's not easy to understand from the drawing. Let me show you something interesting in this question. In the question, if you look at the 3D model, you're not seeing anything about the rib because the rib is kind of hidden. Now, how can we know that there is actually a rib in this question? The answer is this top view. If you look at the top view, you see this weird section. This is called broken section view. So basically, the way that broken section view works is that they give you, it's like an X-ray basically. They are cutting part of the geometry to show you what's happening underneath a specific surface. And here, when they cut this part of the geometry, you can see that there is a rib with 5 millimeter thickness. So that's how we interpret this part of the drawing. Another hint in this question, which is telling you that there is a rib or object underneath this surface, is the front view. If you look at the front view, you can see that this is a circular section, this is a middle section, and we have a rectangular section underneath the middle section, which is basically a rib. So that's how you can conclude that there is a rib with a width of 5 millimeter and also the height of whatever this distance is, from this surface, bottom surface of the middle section to the bottom surface of this circular section. Okay, I hope this is clear. So let's go back to SolidWorks and make this part of the geometry. In SolidWorks, in order to make that part of the geometry, I click on a sketch, and I'm going to choose this bottom surface. Of course, this part is also symmetric. Click on center line and let's make a symmetry line here. What I need here is just a simple rectangle. So click on rectangle command and then make a rectangle here. Now this rectangle should be symmetric, so I click on top line, hold Control, click on center line, click on the bottom line, and from the options let's choose symmetric. According to the top view and broken section view, we know that the width of the geometry should be 5 mm. So this is 5 mm, and that's enough to fully define this geometry. Okay, so now I have this sketch. Click on feature, click on extrude bus. Now all we need to do is to extrude this feature up to this surface. So what I can do, I can click on the drop down menu, and from the options I'm going to choose up to surface. And then here I select the bottom surface of this circular section. And now the extrusion is complete. Click on OK, and that's it. So that's the rib part of the geometry. Okay, so that's it. We basically have all the features made. Now it's time to check the volume and make sure that this is a correct model. So let's go back to the question and check the total volume for this question. In the question, you can see that the total volume is 110,020 cubic millimeters. Now let's go back to SolidWorks and check the volume for our model. In SolidWorks, in order to check the volume, you can click on Evaluate and then Mass Properties. In here, you can see the total volume. The total volume for my model is 110,019.8 cubic millimeters. If you round up this number, you're going to get exactly the same answer as shown in the question, which is showing our model is correct and there's no problem with it. Okay, that's it. That's a wrap for this video. I hope you enjoyed it. If you have any questions, comments, or feedback, please don't hesitate to ask. Thanks for watching. My name is Ruzbe. I hope to see you again soon in the next videos.